So now let's do an implicit example. We'll find the flux of the vector field f equals x squared I minus yz k outward through, how do we want to say this? The surface, which is cut, the surface cut from the cylinder x squared plus z squared equals 4. So this is an infinite cylinder by the planes y equals 0 and y equals 3. No, we should also only want this for z greater than or equal to 0. Okay, so if we let g of x, y, z equal x squared plus z squared, then we're looking at a level surface of G, or part of a level surface of G. So the gradient of G is 2xi plus 2zk. And so this is, since we've got a positive z coordinate, this indeed is pointing outward from the cylinder. So we've got the correct orientation. So we'll take our region of integration to be -2 less than equal x less than equal 2, since we've got a circle of radius 2 in the xz plane. And then our y coordinate, so y is our second independent variable, so y between 0 and 3. Then our formula for the flux of an implicit or over an implicit surface, recall, is, so flux is integral over s f dot n d sigma, but this simplified to integral over r f dot gradient of g over absolute value gradient of g dot p dA. So in our case, that's integral y goes from 0 to 3, x goes from -2 to 2 of x squared I minus yz k dot 2xi plus 2zk, and then we divide by this dot k, so that's over 2z. And since we've got z greater than or equal 0, we don't need any absolute value signs. Okay, and then dx dy. So this will be, and remember that z is square root 4 minus x squared. So this integral becomes integral 0,3 integral -2, 2 of, so this is 2x cubed minus y z squared, or minus 2y z squared. But that all divided by 2 root 4 minus x squared. So this z squared is really a 4 minus x squared. All right, so that looks complicated. I guess we can we can cancel a 2 from everything, so that's not so bad. So this is integral 0 to 3, integral -2 to 2. Let's split this up so it's x cubed over root 4 minus x squared, and then minus y, minus, since we divided by that, so minus y root 4 minus x squared, and then dx dy. So this part shouldn't be too bad to integrate. This part looks, that will be bad to integrate. But notice that, so this function is an even function of x, since we're squaring it. And this function is an odd function of x. And so in total, this whole term is odd. And since we're integrating from -2 to 2, that means that whatever this is, this will vanish. So we don't have to find an antiderivative of that. This term will just integrate to 0. So we got a little bit lucky there. Then for the other term, we can split this up into, so this is, since this is a product, we can split this up into negative integral 0, 3 y dy times integral -2 to 2 root 4 minus x squared dx. So this term, this one is going to be -9/2. This term, instead of integrating this, let's just recognize that this is going to be calculating -2 to 2. This is calculating half the area of a circle of radius 2. So the area of a circle is pi r squared. So this will be, this term will be pi times 2 squared over 2. So that's just 2 pi. And so we'll get the flux overall is -9 pi. And so this is, we should expect the negative, because if you look at this picture, it looks like if this were a fluid, it looks like it's flowing not outward of the cylinder. It looks like it's flowing inwards to the cylinder. But we picked our normal direction to be outward of the cylinder, so this is why we're seeing a negative sign here.